So instead of defining the position of the point A as run and rise, x, y, what if we define it in this way? How far A is from the origin? First, that will be called R. R. How far A is away from the origin 0. 0, 0 is your origin. This makes sense because when you have rotations, you know, if it's rotated on the circle, this is going to be exactly how far it is away from the center. But it's not defining the unique point. There are infinitely many points, same far away from the center. So the first coordinate will be R, and the second coordinate will be the angle. This angle with a positive x-axis, so basically positive horizontal line, called theta. Theta. There's going to be a new way defining the point, and it's not going to be Cartesian equation. That's what we're going to call polar equation. Polar equation. Let's write down what I just said. So, or we just actually seeing this way. We're going to write down that R, distance from the pole, just like in polar idea, where there's a pole, the original point. Well, now it's glitching, seriously. The pole, 0, 0. And then theta, the circle with the wiggly part inside called theta, is the angle with the positive x-axis. And now it defines a unique point. X, y, defined unique point. R, theta, define a unique point. How far I am away from the pole and what angle I have with the positive horizon, for example. So if you're hiking somewhere and you got lost in the woods, you have a radio, you call the station to go find you. They will ask you where you are. There's one way of saying where you are. You can say, well, I am this amount coordinates miles to the east and then this amount to the north. That will be X and Y. The other way to say where you are will be, I remember I walked for 17 miles away from the base. That is from the center, right? And I remember that I was walking towards northeast, somewhere 45 degrees. That's exactly unique location you have now, and they will find you. That's the idea. So, of course, maybe you remember in the movies, you've seen these kind of pictures of the ships. Ships likes to use these ideas because they send out the signal, and the signal will hit the ship, and they will see how far the ship is away from you if you are the center. Or there's an iceberg, right? Would save many people if they would have that information on time. So, and so on. That is very popular, specifically for rotations as well. We're going to do lots of rotations in this class, so it's going to be pretty cool. Now let's find the connection between two coordinate systems. If you put down this line from A down to the positive x-axis, then it creates a triangle. Not just triangle, a right triangle. From right triangle, now we can find the connection between x, y, r, and theta using your favorite Pythagorean theorem. So, connection, formulas basically. X squared plus y squared equals r squared. R is a distance away from the pole, center, 0, 0. Tangent theta is rise over run, y over x, where theta is the angle with the positive x-axis. These are equations that will be highly used to switch between x, y, r, and theta. It all comes from the triangle. X squared plus y squared equals r squared. And then y over x gives you tangent theta. So, very classical idea. Now, if we really want to r, usually from the first equation, people solve for r. R is a square root of x squared plus y squared. It should be plus minus, but r is a distance away from the pole, so it's not negative. It's always positive. And then theta is arctangent, but usually people find tangent of theta and then from there they walk and find what is theta. Finally, the formulas, polar equations, formulas look like this. X equals Y equals, you will recognize them from the exam we had recently. R cosine theta, R sine theta. R is the radius of the circle, theta is the angle, and from here we're going to be creating lots of things. So this is basically the most important formula. We'll be having this in calculus 3, we'll be adding z as the height, and so on. So again, if this is a circle, it's closed. Let's keep rotating, keep rotating. In calculus 3, we're going to add a z value. It will be circle, which will never close, but increase the height. That creates a spiral or a DNA shape, basically helix. We're going to call it helix. So that is the idea here. Now, how to jump between those two? That will be lots of homework questions, you will see it. And on the test, we're going to ask you. So Cartesian, so let's do like so. From Cartesian, they call it rectangular sometimes, to polar. I keep saying it because in your homework you will see it. So many students ask me, what do they mean by rectangular? And then back, from polar to Cartesian. If they ask you to create r and theta, so to jump from parabola to polar equation, and how we're going to do that? You actually create starting like so. Define r. So define r as a square root of x squared plus y squared. Define theta via tangent of theta, y over x, rise over run. And that's how you jump to r and theta with known x and y. If they want you to get rid of polar equations, polar parameters, theta and r, then you know the correlation. X equals r cosine theta, y equals r sine theta. And you will do those tricks we learned from the previous chapter. Square and add both sides. And then usually the parameter disappears, blah, blah, blah. In the first one, they give you x and y. So, given x and y shape. In the second one, where's the line? Given r and theta. Please remember the order. R goes first, theta goes next. So first, the distance from the center, then the angle. This is a basic introduction of polar equations. And now we'll be practicing lots of cool things. Pretty interesting. The moment you define completely new systems of coordinates, everything will be redefined. Parabola will not look like parabola anymore. Line will be different, and so on. So some things were easier in Cartesian, now they will be super hard in polar, and vice versa. Some things are very hard in Cartesian and going to be super simple in polar, and that's why polar are used. So examples, and this is what your homework looks like. Example 1. You can start your homework today if you want to. Find polar coordinates 4. Find polar coordinates 4. So if a person gave you coordinates -2 and 2, they ask you to find your location. Where is that person? Solution. First of all, you need to understand what is given. -2 and 2 can be both. Can be x and y and r and theta. So which one is that? Which one is this? If they ask find polar, so which one is given then? X and y. X and y is given. So a person who is hiking, for example, got lost, and on the radio says, I am -2 and 2. -2 to the, so 2 units to the west, right? That's to the left. And 2 units up, that's south. North, 2 north. And then the people in the station, they have, for example, the signal they're sending. And the signal looks like the bats. They're using this kind of signal that's spread. How will they change from east, west, south, north into how far you are away from the base with the angle. You would use the first way I told you. Build your r and build tangent of theta. Solution. R equals the square root of x squared plus y squared from Pythagorean theorem, which will be minus 2 squared plus 2 squared square root of what? 8. Square root of 8. Which is, for you to know, 2 square root of 2. You can ask me after class, how did I get square root of 2 over 2? So that is how many miles away this person is away from the origin. Square root of 8 miles. Which is approximately 2 miles. 2 point something miles away from the origin. But that does not give you unique location. So if you have system, it looks like this. Now you know that the person is 2 point something miles away from the origin. Origin is a pole, 0, 0. But unfortunately, there are infinitely many points away from the origin with the same lengths. You see? There's a whole circle of points, infinitely many points. Now you need to know the angle. The angle will give this exact unique value. Let's see. Theta. Question mark. What is theta? Usually people find tangent of theta. Tangent of theta has a very straightforward formula. Y over x from the Pythagorean theorem and triangle. You saw in the right triangle. Rise over run. Let's do that. It's going to be minus 2. Actually, y is plus 2. 2 over minus 2, which is minus 1. Minus 1. What does that give you? That's tangent of theta. We want to find theta. So you use inverse functions knowledge. The question is, arctangent, let me ask you, arctangent of minus 1 is what? Usually I teach people like so. Tangent of what angle gave me minus 1? That's how you know. Do you know? Tangent of what angle gives you minus 1? You can check the circle, or you remember tangent of what angle gives you 1, and then use a symmetry. So 3 pi over 4, someone said, or you can go down to minus pi over 4, right? So you use either symmetry or you know the angle. Let me tell you that arctangent of minus 1 has 2 answers. Theta is 3 pi over 4. 3 pi over 4 is located over here. That is the angle 3 pi over 4. But there's also one more answer, which is minus pi over 4. Minus pi over 4 is over here. That means we're going down to the negative side. Remember I told you that clockwise is going to be negative direction, counterclockwise is positive. So when we go to the counterclockwise direction, we go to negative. So now we don't know. So the distance is the same. It's the same distance r. R, let me make it like so. Same distance r away from the pole. We know the r, 2 square root of 2. So now we have 2 points. Which one to use? That is because inverse functions don't give you unique answer. That is the problem. To choose the point, you need to be smart. That's why in this homework you will be a bit confused on this. And they also review trigonometric functions, which you love so much. Trigonometric functions, your favorite. The angle, the hand, remember there's like the trick to learn the angles through the hand, blah, blah, blah. So do you know how to choose? Which one? Yes? How do you know?
Because the points are negative 2 and 2.
We know the point, exactly. It's minus 2 and 2. Minus 2 and 2 tells you that we go minus 2, that's 2 units to the west. So it's already not the one below. Moreover, we know that the second coordinate is positive, which is 2. So we go up, not down. And that's how we eliminate the other point. Good job. Exactly. So the answer will be, you can always choose the final answer based on the first information you're given. So let's summarize the idea. We found, so the first thing that was given was the point minus 2 and 2. We were asked to convert this point to polar coordinates. We found the radius using the formula, how far away this point from the pole 0, 0. R was 2 square root of 2. Then we wanted to figure out the angle. Angle is tangent of this angle was minus 1. Tangent of this angle of minus 1 gave me 2 angles. But the one we choose, based on the information we have, is this one. Theta is 3 pi over 4. So the point A becomes 2 square root of 2. It will not fit. The point A has 2 coordinates now, not negative 2 and 2 anymore, but 2 square root of 2, comma 3 pi over 4. This is a new coordinate. Let me write it down below as well. What we did is, or was, we jumped from x comma y minus 2 and 2 into r comma theta. 2 square root of 2, 3 pi over 4. This has so many applications, it's just insane. I will mention the applications next week, and I have lots of cool links to show you how it all rotates and important and stuff like that. So we jumped from rectangular or Cartesian to polar. We're also going to have, in calculus 3, we're going to have spherical equations. We're going to have cylindrical equations. It's actually pretty creative that people do not always use Cartesian equations. Some things are just too complicated in Cartesian equations. Usually the rotations and the one that requires trigonometric functions. Questions about this? Look how colorful this is. So pretty. Move on. Next homework example is this one. Example 2. Let's go back from from polar to rectangular. Find the rectangular coordinates for, don't forget to switch your calculator when you do homework into radians, or else you'll get pissed way too often. You'll be like, why the answer is wrong? Because you're probably using degrees. Either jump to degrees from pi over 6 or switch to radians. So since we asked to find rectangular coordinates, we are given polar. That means 4 is r and pi over 6 is theta. And they have different meaning now, not run and rise. That's very important. Solution. They ask us to find x comma y. That's what is going on here. This one is easier than the one before. I showed you these steps to do. This is the right-hand side of this table. Right-hand side says how to jump from polar to Cartesian. Just write down x and y. Those are definitions. X equals y equals r cosine theta. Remember, cosine goes first. That is fixed international for the polar equations. Plug in r is 4, that was given, cosine of pi over 6, which is 4 times what? Who remember cosine of pi over 6? Who was tortured in school to memorize all the angles? Some teachers told me some teachers were very strict, like you cannot pass high school if you don't memorize. Some people were not strict, so who knows? Square root of 3 over 2, good job. Square root of 3 over 2. Who have PTSD now from that class in school, trigonometric functions? Multiply, it will be 2 square root of 3. See what we did? We jumped from r and theta. R is how far I am from the pole, theta is the angle, to x coordinate. It's 2 times square root of 3 miles away to the right on the x coordinate. So now we know that. Y is defined as r sine theta, which is 4 sine pi over 6, which is 4. Who can tell me square root of 3 over 2 for sine? 1/2. Amazing. Equals 2. So it's 2 square root of 3 units to the right and 2 units up. What we did, that's it, that's the answer. So this one is easier. What we did was, we were not given x and y. Instead, we were giving 4 units away from the pole. But there's too many of them, so I don't want to draw that first. And pi over 6 is the angle. That's one I know. Pi over 6 looks like, well, that's pi over 4. Looks like so. Pi over 6 was given theta pi over 6 theta. Pi over 6 was given, and the radius 4 was given. Our job was to find the coordinates, so 4 pi over 6 moved to the Cartesian coordinates using the formula, and it became, let me change the color, and it became 2 square root of 3 comma 2. Make sure it also makes sense from the graph. It makes sense because I can see 2 square root of 3 to the right, and then 2, a little bit less, up. So it makes sense. So we jumped from polar to Cartesian. That's good. That's the answer for this problem. What do you think about that? No questions, ideas? It's kind of not very interesting, but it's because it's the beginning. It will get more crazy literally very soon. We're going to learn how to do infinities, hearts, which are called cardioids, hearts with the loops. Apparently, you can control with trigonometric functions how big the loop is going to be inside of the heart. Or maybe there will be a very tiny loop, and so on. So it all starts simple, defining the coordinates. And then after this becomes interesting, which we're going to do right now. Find the equation, and I will give you something random, and we should guess what it is.